Good day. Our discussion has something to do with the geometric sequence, concentrating on the common ratio and making use of the formula. Again, let's recall, when do we say that a sequence given is a geometric sequence? Let us remember, a sequence is geometric if there is a common ratio between consecutive terms. And when we say common ratio, that would mean to say we divide the current term by the previous term. There is a constant number as a result. Let's have an exercise. Determine whether the given sequence is an AP, meaning to say arithmetic progression, arithmetic sequence, geometric progression, GP, or geometric sequence. And you have another choice, which is neither of the two. Considering your 10, 30, 90, 270, 810, 2430, and so on. Is this an AP, a GP, or neither? The answer is it is a geometric progression. For what reason? The common ratio is 3, which means to say we have, if we start from 2430 divided by 810, that would be 3. Likewise, if you have 810 divided by 270, that is 3. 270 divided by 90 is 3. 90 divided by 30 is 3. And 30 divided by 10 is 3, making this a geometric progression. Next, 4, 2, 1, 5 tenths, 25 hundredths, and so on. Would this be AP, GP, or neither? Go. And the answer is it is a geometric progression. Again, if it is a geometric progression, what would be the common ratio? The common ratio is 5 tenths, which would mean to say that if I start from 4, I need to multiply 4 by 1 half or 5 tenths, and I will be arriving at 2. Likewise, for 2, I will multiply that by 5 tenths, and I will be arriving at 1, and so on. Next, -4, -9, -14, -19, -24. Go. And the answer is it is an arithmetic progression. Why is it an arithmetic progression? That would mean to say that there is a common difference in between two consecutive terms. And what would be the common difference? To get the common difference, what are we going to do? The current term minus the previous term, and we should arrive at -5, which means to say we have -24 minus a -19, -24 minus a -19. That would be, do the opposite. 24 becomes plus 19, and the result would be a -5. Likewise, for -19 minus a -14, -19 minus a -14 would still be arriving at -5. And -9 minus a -4 will likewise be a -5. Thus, this is an arithmetic progression or an arithmetic sequence. Next, 1, 4, 9, 16, 25. And as you can see, there is no common difference between terms. Likewise, there is no common ratio between terms. That is why this is neither a geometric progression, neither is it an arithmetic progression. So what then is the pattern here? Observe, that all the terms are actually squares of the counting numbers starting with 1. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and we can still have 6 squared is 36, and so on. Next, AP, GP or neither. 3, negative 6, 12, negative 24, 48. Would this be a GP, AP, or neither? And the answer is it is a geometric progression and the common ratio is negative 2. If you're going to check, 3 times negative 2 will give you a negative 6. Negative 6 times a negative 2 is a positive 12. 12 times a negative 2 is a negative 24. And negative 24 multiplied by negative 2 is a positive 48. Let us take note. In here, we have the terms as alternately positive, negative, positive, negative, positive. If we have a progression, geometric progression like this, then the common ratio would be a negative value. And the last one for this set. The table below shows the heights of a ball's bounces. So the first row will give us the bounce, the first bounce, the second bounce, and the third bounce, while the second row would give us the height in feet. And we have, for the first bounce, we have 200 feet. For the second bounce, that is 80 feet. And for the third bounce, we have 32. Would this be an AP, a GP, or neither? And the answer is, it is a GP. Why? Let us take note. Let's get the common ratio. How do we get again the common ratio for this? We get the term on the right, which is 32. We divide it by the term on the left, which is 80. We get 4 tenths. And when we get 4 tenths, that is not yet the final answer. You can see that 4 and 10 are actually both divisible by 2. So 4 divided by 2 is 2, and 10 divided by 2 is 5. Thus, we have here the common ratio for this geometric progression is 2/5. Now, let us also determine the common ratio and extend the sequence. By extending the sequence, we mean we continue the list. Example number 1. Find the next three terms in the geometric sequence negative 9, 3, negative 1, 1/3, negative 1/9. For us to be able to determine the next three terms after negative 1/9, what is always the very first that we have to establish? By definition, a geometric sequence, there is a common ratio in between two consecutive terms. So we have to determine first the common ratio. So find the value by dividing each term by the one before it. Let's see. So we have listed here the different terms. Now let's start from the right. We have negative 1/9, and we are supposed to divide this by 1/3. And we know that negative divided by positive is a negative. And to divide a fraction, what do we do? Dividing fractions, easy as a pie. Flip the second and multiply. Thus, we now have 3 and 9 are both divisible by 3. And 3 divided by 3 is 1. 9 divided by 3 is 3, giving us 1/3. Likewise, we take a look at 1/3 and the term previous to this. We have 1/3 and we divide that by a negative 1. Any number divided by itself is the number itself, so you have 1/3. And let us remember that positive divided by negative is negative. So we still got the same, which is negative 1/3. Next, we get negative 1 divided by 3. So negative 1 divided by 3 itself is negative 1/3. Likewise, we check for the last. 3 divided by negative 7. So 3 divided by, negative 9. So again, positive divided by negative is negative. And 3 is divisible by 3. 9 is also divisible by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So this similarly we have here, we still get negative 1/3. So we can now make the conclusion that thus the common ratio is equivalent to negative 1/3. So we already have the common ratio. Now we are ready to come up with the next three terms. We multiply now each of the term by, or each, the last term by negative 1/3 to find the next three terms. So we start with negative 1/9, which is the last in the list. We are going to multiply that by the negative 1/3. And when we multiply negative times negative, we get a positive. And then 1 numerator times numerator divided by denominator times denominator. And 1 times 1, we get 1. And 9 times 3, we get 27. That is the next term. To get the next term after 1/27th, we again multiply 1/27th by negative 1/3. So again, positive times negative is negative, and numerator by numerator, 1 times 1 is 1, 27 times 3 is is 81. Thus, we have the next term to be negative 1/81st. Then, for the last term, because we are asked for three terms after negative 1/9, we multiply again negative 1/81st with 1/3. So negative times negative, we get a positive. Numerator times numerator, that's 1. Then denominator times denominator, we get 243. So thus, we were able to list the next three terms of the sequence. After negative 1/9, we have 1/27th, negative 1/81st, and 1 243rds. Next, find the next three terms in the geometric sequence 52 or 54, 162, 486. So likewise, what's the first that we have to establish? That would be the common ratio. And what is the common ratio? How are we going to do that? Again, let us list the terms. Then, from the right, we go to the left. Whenever we start from the right and we go to the left, that would mean to say that the operation that we're going to use is division. So that we say 486 divided by 162, we get 3. Likewise, if we're going to divide 162 by 54, we also get the result of 3. So that we can clearly say and we can confidently say that the common ratio is 3. Now that we have the common ratio, then we are ready to determine the next three terms. So what would be the next term after 486? We multiply the previous by r. So that 486, we multiply that by the r, which is 3. Use your calculator. We have 1,458. Then we multiply 1458 again by 3, and we arrive at 4,374. And we multiply 4,374 by 3, arriving at 13,122. And now we have listed the next three terms in the geometric sequence: 54, 162, 486. And these are 1,458, 4,374, and 13,122. Now, there's a question here. What if the terms are not consecutive? How do we solve for the common ratio? For when terms are consecutive, we make use of R is equal to A sub n divided by A sub n minus 1. A sub n is the term divided by the term before it, which is denoted by A sub n minus 1. But of course, we cannot make use of this if terms are not consecutive. So we're not going to discuss the derivation of the formula. That is done in another video. We can make use of this. R is equal to the n minus x root of A sub n divided by A sub x. X here, of course, let us remember that is a counting number. Likewise, that n. So it could be that we are given the first term. It could be that we are given the 10th term and the 7th term. It could be that we are given the 11th term and the 5th term. And we can make use of this formula. Let us see. The third term of the geometric sequence is 12, and the sixth term is 1,500. What is the common ratio? So we make use of that particular formula. We have R is equal to the n minus x root of A sub n divided by A sub x. And we have here third term, so that would be A sub 3, which is 12. And then we have here the 1,500 to be the A sub 6 is equal to 1,500. So 3, our x here will be 3, and our n here will be 6. So we have the common ratio is equal to, we have A sub 6 divided by A sub 3. Thus, we now have here in the index, we will be having 6 minus 3. So the common ratio, you now substitute A sub 6. And A sub 6 is 1,500 divided by 12. And what do we get when we divide 1,500? Oops, let's not forget 6 minus 3 is 3. And what do we get when we divide 1,500 by 12? We get 125. We get the cube root of that. And of course, how do we rewrite your 125? 125 may be rewritten now as 5 raised to 3. 5 times 5 is 25. 25 times 5 is 125. And we can see here that the exponent is 3. The index is 3. They are equal. Thus, we say R is equal to 5. That is the common ratio. Or again, we may rewrite it as 5, and it has an exponent 3 divided by the index 3. That would be equivalent to 5. So there, we are able to come up with the common ratio without solving first for the first term, so that we can make use of the generic formula A sub n is equal to A sub 1 multiplied by R raised to n minus 1. Again, the focus of this video was on extending the geometric sequence as well as determining the common ratio given consecutive terms, and also even if when terms are not consecutive. I hope you learned something from this. Thank you for listening. Thank you for watching.